Hello, everyone. Welcome to the reinvigorated, or the beginning of the reinvigorated human-centered AI group and seminar series. We're going to try and have some catering for some of these in-person ones. So there's some food if you're in the room. Please come and grab it and then take a seat. And for today's talk, I'm very pleased to welcome Ronald Singh, who is the research fellow in the Human Agent Collaboration, the School of Computing and Information Systems at University of Melbourne. And Ronald completed his PhD in 2018 at the University of Melbourne, and his BCS and Master MCS degrees in computer science from the University of South Pacific in Fiji. And his research interests include multimodal human-agent interactions, explainable AI, intention recognition, and multi-agent communication planning. And you're going to speak to us today about the utility of explainable AI in improving human decision-making.
Okay, so I'll get started. Thanks everyone for coming to the talk. Thanks Mo and Michael for the invite. So today I'm going to share some of our projects that we kind of have done in the space of explainable AI. Yeah, so I'm Ronald. I'm a research fellow in at the School of Computing at the University of Melbourne. I'll briefly give more context about myself, talk a little bit about the different types of projects and grants that I've been working on, my collaborators. I'll pick two projects in the space of XAI, and I'll talk a little bit in detail about those two projects, and then I'll conclude with some thoughts around XAI-assisted decision making that's being floating around, and what we think generally would be some good directions to explore in this particular space. So briefly, I was born in Fiji, where I completed my bachelor's and my master's at the University of the South Pacific. In 2013, I moved to Australia and I completed my PhD in 2018 at the University of Melbourne. And I've been working as a research fellow in human-agent interaction at the University of Melbourne since 2019. Some of the earlier projects that I was kind of involved in, and I'll touch very briefly on this, was on gaze-based intention recognition stuff. So the idea of this project was to use eye tracking in the context of digital games to recognize intentions better. So as part of the initial phase of the project, we developed a computational model that kind of used individuals or players' eye movements and their in-game actions to recognize their intentions quicker and better. So that was basically kind of the groundwork that we did, and we tested this model in various studies, and we had multiple publications in XAI and AI venues. Between 2019, 2020, 2021, we tried to apply this particular model in the context of robotic rehab. So essentially, we partnered with mechanical engineering department at the University of Melbourne, who had developed this robotic system to assist stroke patients perform routine exercises. So if you imagine you're a patient, you're sitting on a chair, you've got a screen in front of you, and there's a robotic agent that is holding your arm and helping you kind of touch different parts of the screen. What was happening at present, or what is happening at present is the intention of the patient is decided by a physician who's standing outside. So the physician is going to touch a screen, part of the screen. That information flows to the robot, and that is the intent, external assigned intent to the patient. And the robotic agent then is going to help the patient touch that part of the screen. So the intention is physically and externally assigned by a person outside, a physician involved in the exercise. What we tried to do was to use eye tracking information to give that responsibility and autonomy to the patient, so that they could actually choose and decide the intentions themselves, right? We did try this particular model with healthy patients. Unfortunately, due to COVID, we could not actually get stroke patients to try this out. And we got a publication out, but it is with preliminary kind of stuff that we did. So, yeah, so that was basically my early part of kind of investigation into intention recognition using gaze. Apart from that, I've worked on a number of other projects. So I was hired to work as a research fellow on the IRC grant on, which is basically human-centered approach to explainable AI. Now, from that point onward, since 2019, I have been a co-investigator in a number of other grants. Some of them around explainable AI, and some of them around other topics, such as theory of mind, kind of reasoning, where we use Bayesian theory of mind kind of reasoning stuff. In 2019, we started some work on exploring the relationship between XAI and narratives. That work led to some of the other grants that I'm going to talk about today. So there's a specific project that we just completed on cognitive modeling and XAI. So I'm going to talk a little bit more about that. Another project that we did as a co-investigator was on foundations and analysis of AI, where we actually used human-centered approach to understand the information needs of people. And we use that information needs to design explanations. And that project also fed a lot of information on the cognitive model project. So I've been really working in this space, looking at different kind of approaches to build better explanations. Right? Some of the collaborators that I've been working on. So I asked the grant on XAI. Some of you probably are aware of individuals on this particular slide. So Tim and Liz, they have a CS and AI background. They were also my PhD supervisors. Frank and Eduardo and Paul, they are XAI experts. And PS is a cognitive scientist. That's actually forming our team around XAI. So we have really we have a diverse team with different backgrounds. Apart from that, I've worked on with other people. So Michelle is another research fellow in our school. I work with her on another XAI project. Henrietta is a PhD student, not mine, but she works actively with us on other projects. How is a PhD student that I'm co-supervising. Her area of work is around model uncertainty. So how can we use explanations of model certainty or uncertainty to actually improve decision making? So we have some work actively going around in that particular space. Joshua and Vincent, they were collaborators with us on the gaze-based intention stuff, and Emma is a research assistant. Bulk of our work, like in terms of programming work, she is actually the person responsible for doing our stuff. The bulk of the project is possible because we have got people like her as part of our team. So now I'm going to briefly talk a little bit about the explainable AI projects. I'll touch on another kind of stream that I did not discuss in the abstract before I look at explainable AI-assisted decision making. So one line of work that we are actually exploring is around algorithmic recurse. So when Sandra Vector and others proposed the idea of counterfactual explanations as one of the post-hoc example-based explainability method, one of the aims that they proposed for counterfactuals was counterfactuals should enable or could enable recourse. That is, allow people to understand what they could do in the future to change the outcome. Right? That was one of the goals of counterfactual explanation. Now, in that paper and kind of full-on works, it was very evident that a single counterfactual explanation wasn't going to cut it. Right? So features in one counterfactual explanation may be actionable for one cohort, but fully not actionable for others. So very quickly, people kind of said, why don't we propose multiple counterfactual explanations? Right? So if I give you 3, probably one of them will be applicable to you. So that will improve actionability. And there's been proposal about, okay, how do we then generate the multiple counterfactual explanations, right? What's the criteria that we use to analyze them? There are various kind of metrics that have been proposed around diversity, proximity, sparsity, etc. Right? What we did in this particular work was to say, okay, what is the simplest way we can make counterfactual explanations actionable, right? And what we suggested was, why don't we give people actions, right? Directives. And so we proposed the idea of directive explanations, right? An example is given on the slide. The first part of that explanation is a counterfactual explanation. So this is in the context of creditors. If your loan is denied, one type of explanation that we could give individuals is say, you know what, your income needs to be above this particular threshold. That's a counterfactual explanation. The content in the italics is what we call a directive, right? Now I'm going to tell you how you can reach that particular counterfactual state. And we envision two types of directives. Specific. Let's say you have a set of actions, some set of actions A, B, C, and D. Directive specific explanation is do B. Directive generic is I will indicate what that set is, but I won't indicate which of these actions you're going to take. Depending on your context, you decide what actions you're going to take. Okay, good idea. So I've got multiple counterfactual explanations, and we have got this idea about directives. Do people like it? So that was the first question. So we did a study to see whether people have a preference for this kind of explanation or etc. Right? So a snapshot of the results of the entire results. Snapshot is shown on this slide. We got people to choose or kind of indicate their preference for the different type of explanations. And this graph is kind of indicating counterfactuals, which is the lower bit. People did not select that in most of the scenarios that we can apply. Directive specific was clearly more preferred. Okay. So this is preference. People like directive explanations over counterfactual explanations. Does this improve actionability? That's an open question. How do we know whether this is actionable or not? But then that leads to a bigger question that I'm going to talk about next, which is, okay, how do we conceptualize actionability? What do you understand about actionability? You could define it, but what are the dimensions? Are there dimensions that we can use for assess actionability? Now, this concept is not new, right? We have instruments to assess trust. We have instruments to assess explanation satisfaction, and we use them in our study, right? Is there an instrument to assess actionability? Right? We could not find any in XAI, but does this mean people have not thought about it? No. Right. So we started looking at some literature. Have people thought about actionability? Have they tried to assess actionability? And we found a number of instruments. Right? I'm going to just discuss very briefly a sample of 5, but there are many instruments that exist. I'll discuss one specifically. So the first instrument that you're seeing there, PMAP, is an instrument that is used by industry in the United States to objectively assess the actionability of materials, right? So if practitioners are generating materials for their patients, they use PMAP. The criteria is listed in the PMAP to see how actionable material is for their patients, right? So there are various other instruments in shared decision-making literature, blah, 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 etc. Right? This work is, we are about to publish this particular work. So we consulted a set of instruments, 5 in total, and we identified 22 questions in total. We had discussions and said, okay, which one of these questions are kind of overlapping and which ones would be relevant to XAI. And we identified 7 questions as our initial tool. Right? And these questions target different aspects: clarity of information that we provide, whether people can understand the reasons, whether it is contextualized, whether people can identify whether there are mistakes that have been made, or whether the information was incorrect, and finally, whether people can decide using the information what they are going to do or what they could potentially do to change the outcome in the future. Right? So 7 questions we think probably form a tool to assess actionability. Good. This is our thinking. Does this actually work? Okay. Can we actually distinguish between the different explanations? So we ran a study. We got people. We exposed people to different types of explanations, and this instrument that we can, not instrument, a tool, and then we got people to actually write these explanations, right? And we tried this with 3 different types of explanations: directive that I discussed, counterfactual, and prototypical. All are example-based post-hoc explainability methods. We got participants to rate the explanations on a numeric scale of 0 to 10. So that's what you're actually seeing on the y-axis, basically the average rating that more than 30 participants allocated to each of the explanation types. And the x-axis are the 3 explanation types: directive, counterfactual, and prototypical. Results are clear. For example, prototypical explanations are significantly worse off in terms of actionability, according to the tool, than other 2 types. What about counterfactual and directives? We were kind of disappointed, but at least we are able to explain some things in relation to directive and counterfactuals. Our conceptualization was, if we include actions in counterfactuals, they would be significantly more actionable, right? What this tool is showing us, counterfactuals and directives are almost equally actionable on, like, for the first 6 questions. The only place where it's different is on question number 6, which is basically saying people can better identify steps using directive explanations than counterfactual explanations. Okay, so what about the conclusion? Well, at least we have a tool now to differentiate actionability of different methods. These dimensions that we are talking about, the 7 dimensions, they are not just thought of from like we did not pick this out of the air. We have grounding in existing instruments that look at this actionability. So I think we have a preliminary tool to assess actionability of explanations. So this is one kind of work that we are doing in the group, which is we're talking about how to generate more actionable explanations. We have this idea of directive explanation, and now we have a better understanding of how to conceptualize actionability that we can potentially use.
Sure, Larry. At what time's this one finish?
Just ask them to mute. Sorry. Can you just mute yourself if you're on the Zoom call?
Okay, cool. So that was kind of a side project. In the abstract, I mentioned about XAI-assisted decision making. So the next bit of the presentation, I'll talk about a project that we are just wrapping up as part of our kind of research group. While we are wrapping this project, as I explained earlier, this work that we did in 2019, 2018, that all kind of resulted in the success of this particular project. So let's get the context right. So what I'm going to discuss is what's the situation that we are looking at, that we're investigating this particular project, and the conclusions then need to be kind of understood relative to that context. So the situation is we've got a human who is kind of involved in multiple tasks, right? And we envision a situation where we can develop an AI that can assist the human complete tasks. We assume that the human is implicitly asking the AI for help. What can I do and why I should be doing this? And the AI is telling the human, okay, this is what I think you should be doing. These are the alternative causes of action. And these are my justifications why I think you should be doing something like that, right? Or to support the recommendations. Specifically, we envision scenarios where the human operator interacts through a user interface. So even, for example, in the context of an operator controlling multiple UAVs or interacting with teams of humans and agents, we expect that interaction to happen through the UI. We are anticipating that the human will be allocated multiple tasks, right? Naturally, the operator is going to bring in their own reasoning into the picture, get the information of the UI, and interact or provide commands through the UI. In this context, now we will develop an AI that will also get information about the task state and about the operator, perform some reasoning, and then help the human make decisions by offering recommendations, alternative causes of actions, and explanations, right? So that is the kind of setting that we are looking at. And in this particular setting, our focus is on the type of information that flows from the AI to the human. And what are we specifically interested in, right? We're interested in exploring the types of information. Do these different types of information actually help improve the decision making? If we have the ability to assess the cognitive state of the operator, can we somehow adapt the explanations so that it improves decision making, it improves trust in the AI, right? And when I say cognitive state, we are interested in two specific aspects. Can we use the operator's assessment, our assessment of operator situation awareness to improve explanations? Can we use our assessment of the operator's cognitive load to improve the explanations? So overarching, the kind of question that we are asking here is, can we improve the operator's decision-making and trust in AI by providing less and most relevant information? Okay, and this is suitable in the kind of context that we're exploring. Recall that I said the operator could be exposed to multiple tasks. So there is a chance that individual will be cognitively loaded, right? In that context, can we do better rather than providing just the kind of explanation, the generic explanation that we would expect in this context? Okay. So how did we actually investigate this particular question? So we had players play a game, a digital game, El Grande. In this game, so in this context, a human player would play El Grande using our custom developed UI, right? Yeah, so the human would actually interact with the UI, play the game, get kind of all the game state information through the UI, have their own reasoning process to make decisions, etc. We then created an AI formally. How do we look at this problem? We look at this problem as a stochastic game. We model this as a multi-agent MDP, and we use Monte Carlo simulations to solve the problem, right? To decide what's the best course of action. So I'm not going in detail into form modeling, but that's fundamental, right? So we developed an AI that could potentially help players play this particular game, right? And what sort of information the AI is going to give people, as I mentioned, through the UI recommendation of medical explanation. But we also equip the AI with the ability to assess the operator's cognitive state, right? The cognitive load and the situation awareness. We've got models. I'll explain more in slightly in more detail about those models when we get to the explanation structure. So El Grande, has anyone played El Grande here? Okay, so it's a pretty interesting game, fully observable. So that fits conceptually neatly with our multi-agent MDP stuff, right? You can have up to 5 players. It's a 10-based game, and it basically consists of rounds. The official game has 9 rounds. We chop off the game 6 rounds to keep the experiment within the limits, right? The fundamental idea about this game is, okay, you've got this space, you've got this area that is divided into regions. Each region has a different scoring mechanism. So some regions are more valuable than others. And what you do, you move your soldiers, units on the board throughout the game to dominate, to get majority in regions. So if you've got majority in all regions, next will you win, right? So that's the idea. Now, in each round, there are 2 fundamental phases, right? One is what you call the power card phase and the action card phase. So if there are 4 players, the power card decides who goes first. So it's not that if you've got 4 players, the order is going to be maintained. The power card determines the dynamics, right? In that time, who goes first. So you decide who goes first in round 1. You decide who goes first in round 2 or last in round 2. Then after the 10 orders decided in a particular round, people choose action cards, which determines how they can change the board configuration, where they move their soldiers to, and they could actually do other stuff, interesting stuff, like I could remove all the soldiers from one unit and throw it back into your reserves, etc. So that's the basic idea. It's an area control game, strategic game that we kind of play with four players. Go up to 6 rounds, decide turn order, make some interesting changes to the board, and obviously your goal is to win the game. Very briefly, we designed a custom UI to help people play this game. I'll very briefly discuss the layout, not in detail. So panels A, C, and E, that's for your game management. That's a central bit. That's where you play, I want to play this power card, I want to play this action card, etc. Panels B and B on that side, that is general management, right? That is helping people manage the games at the sector, right? You're saying, hey, the AI is going to say, hey, you need to play action in this particular game and stuff like that. And panel left is where the explanation actually is, right? So we're maintaining the context. Everything happens to the UI. Now, in terms of cognitive load, so at the top, it's appearing a bit smaller. You'll see game 1 and game 2. So we had players play multiple games, simultaneous games. So we could have you play one game of El Grande, and to potentially introduce a bit of cognitive load, we could ask you to play 2 games of El Grande. Right? So the idea is with 2 games, the task difficulty is higher. Hopefully that induces more cognitive.
At the same time.
At the same time, yeah. So you would have to physically switch between the games. And we did try with 3 simultaneous games, and people did, well, I mean, they almost cried. So it's not easy, but yeah, we really wanted to see cognitive load, right? And this fits neatly with our kind of conceptual framework around the kind of situation, right? So you've got an operator who is exposed to multiple tasks, and this is kind of simulating the particular setting, okay? Okay, so very briefly, I set out the context, and I've just explained how we actually realize the context. We've got human interacting with the UI. AI is going to help the human by providing certain pieces of information. We are trying to answer the following questions. We are trying to investigate which types of information help improve decision making, and whether we can use the cognitive state to kind of produce better explanations. How did we answer this particular question? So we conducted a 4x2 within subject study. Task difficulty 2 levels. 1 game, we expect that to be lower cognitive load. 2 games, we expect that to be higher cognitive load, right? That's our anticipation. And the explanation type 4 levels, right? So what are we doing here? First thing, a baseline, no explanation. I'll give you a recommendation only. I'll not justify my recommendation. Second, full explanation. I'll explain what our explanations were, but basically there is no adaptation. I've got a structure, I'll give you explanation according to the structure. Then we tried 2 adaptation strategies. One was according to the task difficulty. If I think your cognitive load is high, I will present you less information. And then the final condition was, okay, if I think your cognitive load is high, I'm going to give you less information, but in terms of the situation awareness information you need to play the game well, I am going to select based on the model, the most relevant pieces of information. So not only less, but most relevant pieces of information, right? And we're hoping that these 2 conditions would, players would actually excel a lot. So how do we actually assess their performance? So there are various measures that we use. 2 performance measures. Are you really aware of what's happening in the game? So situation awareness. And task performance. Are you able to win the games, and by how much? Right? Then what's happening to your trust levels? The workload assessment, right? We said if we get you to play more games, we anticipate that is going to be higher cognitive load. Do we really observe that? So this was more or less a validation for us, right? Internal validation. And explanation satisfaction. These are the Hoffman's. The trust and the explanation satisfaction are the Hoffman's kind of questionnaires that we use. the situation awareness, we developed that questionnaire and we had a game expert actually validate that as well. Okay, so what does our explanation look like? So our explanations were basically composed of 4 components: recommendations, alternative courses of action, situation awareness information, and background information. Background is fairly straightforward: game rules. Do you understand what a king does in this game? Do you understand what a power card is? Do you understand what an action card is? So those are the background stuff. Recommendations: I think you should play this particular action card. Right? That's a recommendation. How do we justify that recommendation? Okay. The basis of our explanation is multi-objective contrastive explanations. What do you mean by that? We analyze each recommendation or an alternative based on domain-specific metrics. In this game, it's an area control game. What is one obvious metric? Score. What are some other metrics? Board presence. Right? You want to increase your board presence. The higher board presence, the more chances you'll win the game. Right? So we analyze each recommendation based on some domain-specific metrics, and we call this contrastive multi-objective explanation. So recommendations are choose this action card AE because it increases your board presence, but probably according to the score potential, it's not that good option. Okay, here's an alternative action card. Your board presence is bad, but your score potential is higher. Right? The idea is then you could have a different objective than the AI. So by providing an analysis of the options that are available to you based on the domain-specific metrics, we could potentially help you make your decision better. That was the idea. So that's how we constructed our explanation. Recommendations with the metrics, alternatives with the metrics, essay information. What is situation awareness information? Hey, did you notice that your opponent has just moved in this region? Your score and a board presence has gone down. That is situation awareness information, what we call region. Right? So that is how our explanation is constructed. Now, how does situation awareness information come into play? Essay, we have a model that estimates what are the chances that you are aware of a region event. And the basic idea is, if a region event is old event, most probably you are aware of it. If it's something new, then we need to alert you about it. Right? That's a fundamental idea. There's a mathematical model that's sitting behind it, but that's the idea. So we have a model that pushes new information to the top, and old information gets pushed down the bottom. Right? Then how do we use the task difficulty? Simple. I said present less information. Now visualize this explanation as a list of items. We've got recommendation, alternatives, etc., etc. What do we do? Okay, I can't present you all information. High task difficulty from job. So I'll present you less information. Right? And we have a way to organize this information according to priority values so that most relevant information comes first. So what's really happening? We organize this list. Most relevant information to least relevant information, and then high task difficulty, which of this. So now I'm presenting you less information, but most relevant information. Those are the kind of conditions that we experiment with. The results. Does this actually work? Last 2 words. There is no significant difference. Right? There is no significant difference. But if you look at the graphs, you'll get an idea of what's happening. I'll quickly explain the graphs. Right? So we used 2 task performance measures. One was score difference. What is score difference? If you won the game, then what's the score difference between your score and the person who came, or the player who came second? If you have lost the game, then what's the difference between your score and the winning player's score? We calculated those differences, and that's what we are plotting in the first graph on the left hand side. So that's a score difference and the 4 explanation types on the x-axis. Right? No explanation. We put in the full explanation. Right? So if I give you a lot of information, Everything is relevant, of course, but the performance is really bad. Look at the last condition. If I give you less information and most relevant information, that has a positive impact on the performance. Not significantly, but we can't ignore that there's a difference, right? There's a positive score and there's a negative score on average, right? So players were definitely doing better in that particular round. Now, what about number of wins? We also analyzed the number of wins clearly, right? So it seems that providing the most relevant information had a hit in the task performance, but we declare the difference isn't significant, but worth noting. Probably some of the limitations is like we had 12 players provide feedback. It's 48 hours of data, so it's substantial amount of work that we have kind of substantial amount of data that we have collected. So it's not just any of the 12 players. We recruited 12 El Grande players or board gamers. Of the 12, 8 were expert El Grande players. So these are quite good players that we've got. And this was important for our study because we wanted to really try with expert players who are engaged in the task and so forth. Right? And game is basically, if you know, it's not difficult to get people motivated to play games and be engaged in games. Right? That's the strength of games.
Can you read the negative numbers here? So you said the small difference is the difference between the winning player and the next player.
Yeah.
Does that mean that if it's a negative number, the user won?
They lost.
They lost.
They lost, and they lost by a good margin. Yep. So they lost. They had fewer number. They won fewer number of games, but the ones that they lost with higher margins. That's what you're trying to say. And the ones that in this particular condition, when they won, they really won with a good amount of margin. Right? And this is a within subject kind of design. So all participants, the 12 participants, they were all exposed to each of those conditions. So it was essentially 12 participants in each of these conditions.
How long does each game run?
1 hour. Yeah.
48 games.
Yeah.
They played each other?
No. So good question. So what we had was a game of 4 in the 4 entities, human player assisted by AI, and 4 automated players. Oh, sorry, 3 automated players. The AI and the 3 automated players were using the same technology, right? So the AI that was assisting the individual was using Monte Carlo simulation. The 3 automated players were also using Monte Carlo simulation. Right?
And what's the sentence that the pairs they form?
Sorry?
Is that order that pairs they fall to so that there's a pair first executed in the game and announce then the long mode and then goes through the.
Oh no, so we did counterbalancing. Yeah. So the order in which players were exposed to the different conditions, as well as the high and low workload condition, they were counterbalanced. Yeah. So essentially, every individual was exposed to a unique sequence of explanation and workload condition. Yeah.
So, question. Do the players know that the AI assistant is using the same system as the
Yeah. So 48 hours of data, but there was 1 hour additional hour of training. So 60 hours in total, where we actually got people to go through this particular system. We explained the details of the explanation. We provided a 10-page guide to participants explaining what the explanation was about, etc. So we went through that in fair bit of detail with the players. And all experiments were conducted via Zoom. Yeah. Right. In terms of SI performance or task performance, there is something that's positive. Situational performance, not that great. Right? So we developed a custom instrument to assess player situation awareness, and we had a game expert validate it. In the low workload condition, the ones in green, we can see participants are able to answer questions quite well. So 5 out of 7 questions, we asked them 7 questions. In the high workload, the performance is not really that great. There's no significant difference between the explanation conditions, right? So the players seem to be performing well, right, in the final condition, but there is no significant improvement in the SAE. I'll let you speculate as to what's happening. Trust, interesting, right? Report is evident. We don't have any trust, right? So no significant difference in terms of trust level between the explanation conditions. If anything, right, if you look at the last kind of set of bars, the purple ones, the perception appears to be worse, isn't it? Right? And that is the condition in which the players performed the best. So probably the explanation was helping them, but the perception is really, really bad towards that kind of explanation.
So can I ask, would the ground truth be because the AI is performing the same as the opponents? Would it be always correct to trust its advice?
Would it always be correct to trust its advice?
Would that be the best, give them the best outcome?
No, because if that was the case, then we would have seen this graph would have been different, right? Because the same AI is being used in all conditions. That's not the case, right? So if you basically sit down and accept their recommendations, you should see the same kind of on average, because this is an average kind of plot. You'd see the same average points. You would generally see the average number of wins. That's not happening really, right? We think the reason why there is no significant difference is the explanation is not either helping people develop trust or deteriorating trust. Okay. I think it's important to understand that people are anchoring their trust with the system, with the AI. And the same AI is being used in all 4 conditions, right? So irrespective of when you're actually being exposed to explanation condition, the underlying AI that is kind of helping you is the same AI. So you are anchoring your trust to the particular AI. So the explanation is neither helping nor deteriorating trust. And so we think that is one of the main reasons why we are not seeing a significant difference. Probably there's some impact of explanations, so perception towards the adaptive explanations wasn't that great, right? But there's no significant difference. And we think that's the reason.
It's interesting. There's been work that's showed that sometimes people are more trusting just because of the existence of an explanation.
Good point. I'll touch on that a little bit, right? Okay. And the final point that I want, sorry.
Yeah. So if I was an experienced player playing that game and I knew that, if I follow the AI, I have 25% chance of winning, then I'm going to think, well, the fun part would be to try to do better than 25%. Right? So if I just follow the AI, I'm not going to achieve much and it's not going to be fun. So I'm going to look at what the AI says because maybe it has good ideas, but I want to make my own decision, which I think is what we were hoping for anyway, right? But the fact that I know that my performance is going to be capped if I follow the AI is a reason for me to not trust it, which is also something said. And so my point was, for example, if you take, let's say chess, right, where the AIs are super developed and you can say, oh, I want an AI at that ELO, right? You can tell the user you're fighting an AI at ELO 2000, and the AI that helps you has ELO 2500. Then you could vary the AI ELO that provides the advice and see to what extent people trust it more or less. Because I think that the fact that players are experienced and the fact that they're fighting the same AI that helps them is sort of a confusing situation where people might have conflict with following the advice and not necessarily trust the AI more than they trust an expert. I mean, if it was like a certified expert, he told the players, "Oh, this is an expert," compared to who you're playing against, then there's a reason to follow it. But otherwise, yeah, that's all the things. I think we just need to make the same very much for where the AI was actually better, right? Or would really tell that the AI is better.
Mhm.
Otherwise, why follow it, right?
Yeah, that's a good point.
Or if they're not experts, right?
Yeah, there's something interesting with this particular data. So essentially, the win rate for the human player is around 33%, right? So the players quickly realize that, okay, so the AI is pretty good. It's beating me a lot of the time, right? So I need to put in a little bit more effort. But there's something else interesting that we kind of, yes, I'll come back to it. So while people have their own way of playing games, they have got their own strategies. There were expert players, like they were connected on they're connected, obviously, right? They realized that the AI has some interesting strategies that they never explored in this particular game. So they were also learning from what the AI was doing. So that's, I think that's, while your point is correct, I think there's also this idea that people, it's not that people are not going to look at the AI. Once they're exposed to it, if they see something interesting, they're kind of trying to understand why that's happening, right? And then learn from it. So they're both sides of it, right? Yeah. Sorry.
That if you are really an expert player and having an eye that has a great lower rank than you are, it cannot help you. So you already outrank the AI. It cannot provide you that much more advice or that much more strategies you haven't seen. And I think maybe if there were like players who just started, for them the AI would be way more useful. But it's like having an eye for chef, and you ask for the fisher to take advice from like not like a medium AI. You would not take that advice.
Yeah, I guess the accuracy is something that we could potentially explore and kind of judge. But from the results, I think it's we're happy to conclude that the AI was reasonably good, and people did recognize that quite early on that the AI is able to beat them at playing the game. So the opponents were also good in that case. So probably there was a motivation, but yeah, I mean that's an interesting point. I think it's good to understand the dynamics or the conditions under which people may engage or may not engage with the AI, and their competence is definitely one potential dimension. So I'll quickly touch on one other aspect that is a bit concerning, right? And that's what I'm going to kind of conclude my talk with, is people were engaging more with the recommendations than with the actual explanations, right? So we had recommendations and explanations supporting the recommendations. People perceived that they engaged more with the recommendations than with the actual explanation, right? And we did some qualitative analysis, and that backed our analysis. So, okay. The behavior of the players were, they looked at the initial parts of the explanation, and the recommendations appear at the top, okay? And they ignore the other bits. That's an important implication. Particularly, we really want important bits to be at the top, right? Some people don't engage with the explanations. I'm an expert.
Yeah.
I don't want to use. We had a couple of players with that perception. Players mostly look at the recommendations, and also players stop looking at the explanation when they agree with the recommendation. Right? So all in all, there's a concerning problem here, right? And that is, we as designers come up with explanations. I'm not talking about recommendation. Recommendations do this. Why you should be doing this? People are looking at the recommendation, stopping, not looking at the explanation. Right? And the explanation is, these are important aspects, right? There are various reasons why it's important. One of the reasons is AI is not 100%. It's not accurate every time. So you want people to really look at that information. So now I'm just going to quickly cover some of the content around this particular problem. So we've got some positive results, but there's a bigger question. How do we get this engagement, right? So, this is now becoming a known problem in this particular space. We started this problem. Let's equip people with AI. That will improve the decision making. Didn't work. Let's equip the AI with ability to provide explanation. Okay, good. Still problems. What's really happening, right? Why are we failing with this engagement? Some ideas. Okay, have you thought critically whether the information that you're providing aligns with the user objective? If it's just an explanation that you think is good, and it's not aligning with the user's goal, people are not going to engage with it. So that's one problem that we need to kind of solve, right? How do we do that? There are XAI methods, cognitive task analysis, that will give us better idea about what are the information requirements. We are kind of engaging in those kinds of stuff. But there's also another aspect that we're realizing. Okay, do we really understand how people reason? Do we understand their cognitive processes? Are we providing information that is linking or kind of leveraging that understanding, right? Yeah.
Doesn't the recommendation kind of bottom line the explanation? What's the point of reading the explanation if I already know the recommendation? What are you hoping that the user is supposed to get from reading the explanation? Are they supposed to infer a new recommendation? An alternative recommendation?
So the idea behind it,
if I follow your advice, and your advice leads me to a good place, right? But what?
But how would you know?
want to use one thing, right? And it's telling you want to turn left, but it's telling you to turn right.
Yeah.
If you're gonna need an explanation for why, otherwise you just do what you wanted to do. But
Yeah.
if you're not even engaging with the explanation, there's no way for it to convince you that this is the better move.
Right, but Dan's point is you could turn it right anyway, and it says turn right and says why it's telling you to turn.
Oh, well,
You
but
don't
that
care.
makes sense. That makes sense. If it's telling you the same thing, I don't need an explanation. It's when it's different.
But even then, if you're still learning, you need the explanation because you want to understand. If you play that same game like 10 times in a row, there's a point where I would say, okay, I don't care. I really don't care. Just now, it's like
There is a difference depending on the level of expertise, I agree, of the user. But even experts, I think it's really key, when even more important for experts, when it deviates from what they want to do, that they read the explanation and understand why.
But what I mean, for example, like in the beginning, it's tricky to read the introduction with the storyline, but then if you get really into the game, you just skip the dialogue to to stay in the game, play the game. And it might also be here that in the beginning you read the explanation because you want to understand, but then you're there to play the game. So there's a point where you just might skip it to just stay in the game.
I think the point is to provide good explanations. You need to understand intentions, and understanding intentions is.
Yeah. So the kind of information, yeah.
So I think that if you have a game, it might be a bit different that if you have, I don't know, making money, whatever. Because if you play a game, the ultimate game, the goal is just not purely winning, right? You want to win and have fun. And if you tell me, oh, you have a 25% chance to win if you just follow blindly what the AI says, or your chance might not be as good as 25% if you just do what you want to do. I'm going to do what I want to do. Because I get no reward if I just follow an AI and win. It does nothing to me. Right. So if I try my own things and if I win, that's when I get rewarded.
Yeah.
Just to give money if you win. Nobody fix it. Yeah. So you're not playing for fun. And if you believe that the AI is helping you, then you're always going to follow it and actually trust it. But then you have to trust, I guess.
But the other thing is that even if it's not an AI, if I have somebody who's super good next to me who's telling me everything that I should do, I'll just play instead of me. But why?
No, exactly. So then that case, hopefully it'll not work. But if that's doing the game,
That's a fair point, I think. Right? So, but we need some tasks to try this out. But I mean, that's a-
solutions, you know.
that's a limitation of the kind of context that we're kind of looking at, looking kind of in a But-
Yeah, exactly, right? Maybe it's like, you know, if you stand to make some not insignificant amount of money, then maybe you'll be more tempted to follow the advice. And if the advice can actually tell you, you know, percentage chance of winning this for that move, this for that move. And another thing is, if the player doesn't see their move listed there, right? Maybe they would want to know what the chance of winning would be for them.
Yeah,
That's
of course.
Let's maybe let Ronald just finish off as we're.
Yeah, so
Yeah.
it's so interesting.
Yeah, no, but that's the kind of those are the points that are now being raised and that we need to consider a bit more seriously. But yes, a recommendation is important. Sorry, recommendation is important probably, but explanations are kind of what we really want people to look at. So I was just making this particular point that now there's this push towards, okay, have we really got this idea about cognitive processes sorted, and are they helping us? So there are other pieces of work, for example, around cognitive forcing, which saying don't give recommendations at all, right? Just give explanation, don't give recommendation, or hold off recommendations and so forth. What's the fundamental idea? Is we're trying to understand how people reason and how we can really engage with that reasoning process and provide the right type of information. And the fundamental idea behind the other work that I just showed in this piece of work is we need to understand how people reason. Right? Without a better understanding of that, we are not going to get this engagement problem kind of sorted. Right?
Just thinking a little bit about the discussion we just had.
Yep.
Is the issue perhaps that there's a mismatch between the objective according to the AI and the objective according to the human, right? That's what it sounds like, right? The human's interested in the payment. The AI wants to win. And it's like in Kira's example, right? You can have a different game where it's like, oh, making money or something. Suddenly we agree.
Yeah, that's a good point. And probably one of the reasons why we were trying to explore this multi-objective kind of contrastive explanation was around that idea. Can we provide an analysis based on set of objectives that you are interested in, and why these options are using that? Probably that is going to be a bit more engaging for you. So we do recognize it, but yeah.
But this is like a zero something,
right? Then this appropriate reliance that we just talked about. How do we actually get people to use the AI in the right context? We need to sort that particular problem out. Probably we can identify offline regions. Okay, in this particular for these decisions, the AI is not really that good. Don't use it. These regions where the AI is good, we are actually comfortable using them. So that's another idea about the kind of information that we can actually provide individuals to kind of improve appropriate reliance so that they can use the AI in the right context. Probably, a more mentioned, people tend to actually just accept the AI recommendation if it exists, or even with the presence of explanation, that is worse. Right? So if I give you a recommendation and explanation, there's a higher tendency for you to accept that recommendation. Probably we can use that as a tactic. If I know that the AI is good, I'll give you an explanation to increase the chances that they're going to accept it. Whether it's good or bad tactic, I'll let you decide. But those are some things that are floating around, right? And also the idea that probably explanations are inducing cognitive load. Can we do better? So our work is actually in that particular space, and we have some promising results in saying, if you provide less and most relevant information, probably it's going to be more effective. So I'll just wrap up with few points that I think are important for us to sort out if we really want to look at engagement with explanation. One, we need a deeper understanding of cognitive processes, how people reason, to link up with those processes and get people's engagement out. Probably thinking about system 1, system 2 kind of thinking, that's going to be helpful. I'm not really sure. Provide people information so that they can judge when I should be relying on AI and when I should not. Make sure that the information aligns with the user's goals and objectives. And I'll let this from my side, make sure that the information aligns with the user's cognitive state, because I've clearly seen that to be having a positive impact. So with that, I'll quickly just wrap, I'll stop. Some references. Thank you for listening.
Thank you so much, Robert. So, we are out of time, but we did have conversations as we're going. Are you in a hurry or can you stay? for-
No, I can
Anyone have-
stay for a bit.
Any further? Yeah.
Thank you for the super interesting presentation. So I like that you made those qualitative analysis about, okay, what are people actually doing on top of the questionnaire results that we got. So I wonder if you have any more like detailed analysis of how the dynamic unfolds. Like you mentioned, for example, you were using gaze for the like the stroke representation. And then if you collect, for example, face data of where the person is looking at on the big board, that could also show you like how long they spend reading the explanation, for example.
Yeah.
So maybe at the start, they were like paying attention to the explanation, but as the game starts to heat up, maybe now they focus more on the board instead of like on the explanation itself. So I wonder if you have planned to do that, or you already have some data on that.
Actually, that was the whole idea behind this project, was to use eye tracking to understand, develop that understanding. But something terrible happened, which is COVID, and so we appeared in that with our endeavor. And unfortunately, while I was doing this data collection, at the middle of it, I got COVID. So I had to do all the experiments online. So there is definitely intention to use eye tracking information to get a better understanding of that the dynamics actually.
Yeah, I mean, it's like if you ask people a questionnaire at the end after an hour of intense two simultaneous games, my brain would be fried. I forgot everything that I have been through, and I read the trust questionnaire, going, oh yeah, maybe I can't remember, so I'll just mark everything as 3 or something. So that might also, I guess, make the effect less obvious.
Probably potential, yeah.
Question on, so you know that that scale you had about how much user actually uses the recommendation, the explanations. I was curious to know between the expert players and the non-expert players, what's the distribution of.
See, the unfortunate thing is like we had 8 expert players. When I say expert players, they were El Grande players, and we had 4 non-novices. They're not clearly novices. They were game boarders, but they had played probably 1 game of El Grande and so forth in their lifetime and so forth. So we had 8 expert players who regularly play El Grande. Then we have 4. The distribution is quite skewed, right? So if I look at 8 players, probably the data that's what you're getting, and with 4 data points. I mean, we can do the plots.
Yeah. So why I was a bit curious was because, like, for the expert players, once they see the explanations, they start to know how the AI thinks, and maybe they can provide their own counterintuitive counterattack for that strategy. With recommendations, like maybe they could follow, they could not follow, but once the explanations come in, they kind of have a feel about how the AI thinks, what it's planning to do next, the risk and percentages of tasks it may do. So that's why I'm thinking it'll be interesting to know what the experts do with that information compared to the novices.
Yeah, that's a good point. That's a good point. Probably we need, I need to go back and kind of code the data in some way to actually understand that. We haven't quite looked at the data in that detail, but that's an interesting point. Cool.
Thanks.
Okay,
Thank you so much.
Thank you, Rana.
Okay. And if you have any follow-up questions, my email is on the slide. You can contact us.
And our plan for these is to have them fortnightly going forwards, as a sort of Friday lunch.
Thank you.
Cool.